Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on Introduction to Chemistry. And today we are going to be looking at the non-luminous flame. In our previous lesson, we looked at the luminous flame and also discussed different regions and even how the luminous flame is produced. And we looked also at the advantages and disadvantages of the luminous flame. So you can go back and check out the video so that you can be able to learn a bit more on the luminous flame. For today, we are going to be learning on the non-luminous flame, and we're also going to learn on its regions and even how it is produced. And then we are going to look at one question in regards to what we are going to discuss. So let's begin. So the non-luminous flame is usually produced when the air hole is open. So when the air hole is slowly opened, more air enters into the chimney. And then when air enters into the chimney, it means that there will be a complete combustion. The air will mix with the laboratory gas and it's going to burn completely. So the yellow color slowly turns into blue, and so the gas that is going to be formed is usually pale blue in color, the flame that is going to be formed. And we usually call this flame the non-luminous flame, which comes from the word illuminating. So this is not illuminating, it's not that bright. So that's why it is referred to as non-luminous. So non-luminous flame does not give a lot of light. Sometimes even you may not be able to see it when it's lit from afar because of how blue it is. It burns completely. And an example is on the photo given. It's burnt the blue flame and it's burnt completely. It usually has three regions, unlike the luminous flame, which has four regions. It usually burns with a roaring sound and it's very steady and small, unlike a luminous flame, which is very large and wavy and quiet. So we are going to look at the regions in the non-luminous flame and see what happens in each region. So the non-luminous flame has three regions. We have the pale blue zone, we have the green blue zone and almost colorless zone. And in the almost colorless zone, it mainly consists of unburnt gases. This is directly next to the chimney where the gas is coming from, the laboratory gas and the air. So these gases that are in this place are not burning, they are unburnt gases. That's why it's almost colorless. We also noticed the same thing when we were discussing on the non-luminous flame. The luminous flame, it also had a colorless zone, and it's because of the unburnt gases. Next, we go to the green-blue zone. It usually contains some partially burnt gases and also partially unburnt gases. It's not completely in the same manner with the luminous flame. The amount of gases that are not burnt completely are less, but also we have some gases that is burnt completely in this region. Remember, it's directly above the almost colorless region, so we know some unburnt gases might go upwards as well. As they get burnt, they start forming that green blue color. And then as you go further into the outer zone, which is the pale blue zone, the gases usually burn completely because there's plenty of air. First of all, the air is getting in from the chimney, and also there is air surrounding the flame. So there is complete combustion on this flame. So the non-luminous flame only gives a small light. So because it has very fewer hot carbon particles, so it's not that visible. It's very hot. So when you look at some of the characteristics of non-luminous flame, it is usually small, it's noisy, and it's blue in color. And the region has three regions. The flame has three regions, and it usually produces a lot of heat. This is contrary to what we noticed with the luminous flame. and does not produce soot, because you notice there's a complete combustion happening in this place. So there are no carbon particles being deposited, unlike for the case of luminous flame. And then it produces less light. That is the reason why it is advisable to turn, when you are done with the experiment, you turn it back to luminous flame, because the luminous flame is more visible, because it's yellow and it's bright and it's large. So next, we'll look at the advantages of non-luminous flame. So non-luminous flame is advantageous in that it gives out a lot of heat. It is very efficient in heating. So that is the reason why we prefer it in the laboratory. It is very good. It produces a lot of heat. And then another reason why it's very advantageous is because it does not form soot. So the apparatus are usually left very clean. So this is completely contrary to what we notice with an luminous flame. It usually dirtifies the apparatus. And then some of the disadvantages of this non-luminous flame, it usually uses a lot of laboratory gas because there's complete combustion. So most of the gas is being used up. And then it's not used for lighting because it does not produce a very bright light. It's very dull in color because the blue color, the pale blue color is not that visible. So we do not use it for that we do not use it for lighting purposes. We can only use it for heating purposes. So those are the advantages and disadvantages of the non-luminous flame. So next, let's look at one question concerning the non-luminous flame. So the diagram below shows apparatus commonly used in the chemistry laboratory. So you can see that is the Bunsen burner. So what is the name of the above apparatus? You have said it's the Bunsen burner. And then question 2, label the region of unburnt gases. We said unburnt gases is in the region called almost colorless region. And we said the almost colorless region is the one that is below on the flame. So that is going to be region R, which is made of unburnt gases. Finally, what would happen if part B is closed? So part B is the air hole, and we said if the air hole is going to be closed, there will be no air entering into the chimney. So no air will enter into the chimney. So if no air enters into the chimney, we know that there won't be any complete combustion. So the flame will turn yellow. It will turn to a luminous flame. So that is what would happen. So you're basically explaining what you're going to see and why you're going to see those observations. So that's it on the non-luminous flame. Later on, you're going to look at if you heat substances with both luminous and non-luminous, which one would work best. So see you in the next lesson.